Today, we're digging into one of the biggest challenges in modern medicine, catching Alzheimer's disease early. And it turns out artificial intelligence is bringing some brand new and very different tools to the fight.
See, that's the whole problem with Alzheimer's, isn't it? It's sneaky. The disease is quietly rewiring the brain long before anyone notices memory loss or confusion. So by the time a diagnosis is made, a lot of damage has already been done. The real question is, how do you find the clues before it's too late?
Well, it turns out we have two new detectives on the case. And these aren't your typical investigators. They're both powered by AI, but they look for clues in completely different ways, in totally different places. Okay, so to get started, we need to understand the evidence we're working with. Alzheimer's basically leaves behind two kinds of clues. First, you've got the physical evidence, the hard biological traces, like protein buildup or changes in brain size that you can actually see on a scan. And then there are the behavioral tells, these really subtle shifts in how we talk, in the words we choose. To crack this case, we have to learn to read both.
And make no mistake, the stakes here are incredibly high. Back in 2018, there were 50 million people living with dementia around the world. That number is on track to triple by 2050. So yeah, this is way more than just a scientific puzzle. It's a full-blown global health crisis, and it's screaming for new solutions. All right, let's meet our first detective. Think of this AI as the forensic specialist. It's the one in the lab coat, carefully examining the physical evidence, those super detailed MRI and PET scans of the brain. And it's looking for tiny patterns completely invisible to the human eye. So how does this actually work? Well, it's pretty much a four-step process. First, it just gathers up all the data, the raw scans. Next, it does some pre-processing, which is kind of like cleaning up the evidence, making sure all the images are standardized and comparable. Step 3 is where the magic really happens. This is when deep learning models, particularly things called convolutional neural networks, get to work. These things are just brilliant at finding hidden signatures of disease in images. And finally, step 4, it gives you an outcome, classifying a scan, or even predicting how the disease might unfold over time. And you know what? This detective is good. Some of these AI models are reporting accuracy rates of over 95%. That's for telling the difference between a brain with Alzheimer's and a healthy one. That's an absolutely incredible number. But hold on, it's not quite ready for prime time in every clinic just yet. There are some real hurdles. A big one is that many studies are based on small sets of data. This can lead to something called overfitting, where the AI basically just memorizes the training examples instead of learning the general rules. Plus, there's a lot of inconsistency between hospitals in how they take the scans, which makes it hard to trust the results everywhere. And what researchers are finding is really interesting, as you can see here. This detective works best when it's not working alone. The science is shifting toward what they call multimodal approaches. That means combining data from different sources, MRIs, PET scans, patient history, you name it. The more clues you give it, the stronger the case gets. Okay, so now let's meet our second detective. And this one is a whole different ballgame. This isn't the lab tech. This is the expert interrogator. This AI doesn't need to see a scan. It just needs to listen. It analyzes our speech, listening for those almost imperceptible tells that hint at cognitive change. This whole approach is built on a really simple human truth. Long before any doctor is involved, it's the people closest to someone, their family, their friends, who notice something's a little off. They hear the slight hesitation for a word or the way a story is told just a little differently. This AI is trying to develop that same kind of intuitive ear. So to see just how good this AI detective is, a recent study did something really clever. They took transcripts from people, some with dementia, some without, describing a picture. Then they gave these transcripts to both regular people and to large language models, LLMs for short. And they asked both groups a simple question: does this person sound like they might have dementia? And the results were pretty fascinating. The humans, we were kind of all over the place. We tend to focus on just one or two obvious things, and sometimes we even get it wrong. But the LLMs were much more sophisticated. They picked up on a whole range of linguistic patterns that actually lined up way better with what clinicians look for. But, and this is a big but, there's a catch. For all its smarts, this detective has a serious blind spot. Both the humans and the AI models had a strong bias toward what we call false negatives. In simple terms, they were way more likely to miss a case of dementia, to say someone was healthy when they weren't.
So now we've got our two detectives. We've got the forensic specialist who's highly precise, and we've got the interrogator who's super accessible. So let's pull out their files and put them side by side. And right here, you can see how their skills really complement each other. The brain scan AI, its strength is its precision. It's looking right at the biology. But its weakness, it's expensive and you need a clinic with all the right gear. The language analysis AI is basically the opposite. Its strength is that it's unbelievably cheap, easy to scale, and accessible to anyone with a phone. But its weakness is that tendency to miss cases.
So where does that leave us? What does this all mean for the future of diagnosing Alzheimer's? Well, it's becoming crystal clear that neither one of these detectives can solve this mystery on their own. The real answer lies in teamwork.
And that brings us right back to that multimodal solution. Just imagine a system where our two detectives are constantly sharing notes. The language AI could become this incredible, accessible screening tool, an early warning system that flags people who might need a closer look. And then the brain scan AI could step in to provide that definitive biological confirmation.
But for any of this to actually work in the real world, we need one more crucial piece of the puzzle: trust. Doctors are not going to rely on some black box algorithm they don't understand. And that's where something called explainable AI, or XAI, comes in. Think of it as the detective having to show their work, explaining exactly how and why it came to a conclusion. That transparency is absolutely non-negotiable if these tools are ever going to make it into your doctor's office.
And this really leaves us with a pretty incredible thought, doesn't it? We're heading into a future where medicine is becoming deeply personal. So just think about it. Will your future checkup involve an AI that not only analyzes the intricate details of your brain scan, but also just listens to your stories?